My name is Mike, and I'm going to be doing a presentation today on permutations and combinations. Let's start. So the objective of our today's lesson, we're going to use permutations and combinations to count possibilities. There are things that you need to know that I might use during the lesson, and that's the number of alphabets, which is 26, and the number of digits, which is 10, and the digits I'm talking about is 0 to 9. So in fundamental counting principles, I don't know if you've met it before, but in fundamental counting principles, we say when you are doing this and that, you multiply. And when you are doing this or that, you add. So for instance, if there are 25 dogs and 10 cats, how many ways can you choose a dog or a cat? So we are going to add. So we're going to say 25 plus 10 will give us 35 ways. So there are 35 ways you can choose a dog or a cat. Okay, let's make the second example. How many ways to choose a dog and a cat? So we are going to what? We are going to multiply. Remember the fundamental counting principles, because that we'll be using it a lot in the coming examples. So we are going to have 25 multiplied by 10, which is going to give us 250 ways. All right then, there's a bit of vocabulary. As you know, in mathematics, we use a separate language, as much as in chemistry, they use separate language. So in this study of a piece of probability, which is permutations and combinations, we use these following. N factorial. Understand what n factorial is. N factorial is when you multiply a number with all the numbers that are less than that number. An example of that is 5 factorial. So 5 factorial is 5 multiplied by 4, multiplied by 3, by 2, and 1. Okay? So you need to know. So what would be 20 factorial? So that would be multiplying 20 times 19 right up to 1, right? Okay, and 0 factorial is equal to 1. Don't ask me why, but let's just use it like that for now. 0 factorial is equal to 1. Okay, now let us define what permutation is. Permutation, it is an arrangement of items. We are arranging items, and remember this, the order that you arrange these items matters. And combination is quite the opposite. Combination, we're just combining items, and the order that you combine them doesn't really matter. And you are going to know more a little bit on this. Okay, now I will make an example. So I want us to be able to talk about them, but then to derive what the formulas that we use when we're calculating these combinations. Okay, let's say you have A, B, C. Letter A, B, and C. That can be rearranged as CB, as CBA. So now you have a different arrangement. Here it's A, B, C. Here it's C, B, A. So the arrangement, two different arrangement. So we are going to say, therefore, the permutation is what? Is 2. Why? Because the arrangement is different. It's like if you have a bank card and you have a PIN code, and this PIN code is a 4-digit PIN. If your PIN code is 3215, you've got 3, you've got 2, you've got 1, you've got 5. You cannot start, you cannot go to the ATM and punch in 2, 5, 3, and 1. No, you won't. You have to follow the same combination. That's why the order matters. And this is where we use permutations in real life as well. Okay, what about combination here? What would you say the combination here is? The combination here is 1. And why is it 1? It is 1 because you used the same combination of letters as here. It's still ABC, right? So that's why the combination is 1. Let's take, for instance, plov. We have 4 letters. And the question that I want to ask here is, how many 2ID combinations can you create from plov? Let me ask this again. How many 2-letter combinations can you get from plov? And how many 2-letter arrangements can you get from plov? So here, the best way to do this will be to put down all those combinations and arrangements. So let's go ahead. So you can have PL, you can have PO, you can have PV. So that's 2-letter, 2 letters, okay? You can have LP, you can have LO, you can have LV. You can have OP, you can have OL and OV. And you can have VP, you can have VL and VO. All right, so in this case, you see that the arrangement, we've got how many arrangements? We've got 12 arrangements. And this is your permutation, because there is 12 arrangements. But you'd say you have PL and LP. PL and LP are different, are 2 arrangements. They are arranged differently. Okay, so we have 12 arrangements that are totally different. And here we said the order does matter. The order matters. And here the order does not matter. So let's go to combination. How many combinations are we having? Okay, let's look at that. So in this case, because we said in combination, the order does not matter. So if I choose here PL, I don't need LP because it's still the same combination of L and P. If I choose PO, I don't need OP. And if I choose PV, I don't need VP. If I choose LO, I don't need OL. So I am cancelling out all the repeating combinations. And if I choose LV, I don't need VL. And if I choose OV, I don't need VO. So how many combinations do I have all in all? 1, 2, 3, 4, 5, 6. I've got 6 combinations. And here I had 12. Remember, in combinations, I didn't count the repeating ones. Of all these 2 letters that I chose here, I had a total of 4. And I chose 2. Of all the 2 letters, I didn't count the repeating ones in combination. Okay? Now, let's look at how can we look at this and we derive the formula. All right. Remember, plov had 4 letters and we chose 2, right? And now we want to create, and we know that our combinations here, permutation was 12, combination was 6, right? So now we're saying out of a total of 4, we chose 2. We can say N pick 2 if that helps you. But then how did we do that? How did we do that? We took 4 times 3 times 2 times 1. But then we only wanted the 2, right? But how do you remove these, therefore? You remove these by dividing them. So here, you divide by 2, times 1. And this is 2 factorial. So that would be the same, therefore, as saying 4 factorial. This can also be written as what? As 4 minus 2 factorial. So what do we have here? We have a formula. We have this formula here, but let's see if it's going to give us 12. So 4 factorial, let's see if it's going to give us 12. Anyway, we know it's going to give us 12 because 2 times 1 cancel out with that and you get 12. So, but let's use it. Let's give this n, and that will be n there, and let's give that k. And now we're going to use variables here. We know that the total that you're given is n. You pick 2. That will be n factorial divided by n minus k factorial. So that is our formula. That is our formula of permutation. But how do we use this, therefore, to get our combinations formula? To get our combinations formula, remember that in our combination, our 12th combination, we chose 2, and out of that 12, we took out the ones that were repeating. The ones that were repeating, we took out, all right? So now we are going to say, if you have 4 choose 2, you have a total of 4, you choose 2, what are you going to have? So we know that we had 12. We had 12, right? Initially, we had 12 combinations. So 12 was given using this formula, right? We got 12 using this formula. And so that would be n factorial divided by n minus k factorial. But then divided by what? Divided by k factorial. And what was this k factorial? Remember that we chose 2 combinations, right? We chose 2 letters. And out of all the 2 letters, we took out the repeating ones. We took out the repeating ones. So that means we divided all the ones that were repeating. So therefore, as you know, that would be n factorial divided by n minus k factorial and then multiply by k factorial. So now we have our formula. So we can say, therefore, n choose 2 is equal to n factorial n minus k factorial multiplied by k factorial. So that is our formula for combinations. All right, so in the next video, we are going to look at how we are going to use these formulas to calculate possibilities.